Okay, sorry about that. So in um, part A is the question is find. Okay, so you throw a straight ball straight up from the edge of a cliff. It leaves your hand moving at 12 meters per second. Air resistance can be neglected. Take the positive y direction to be upward, and choose y equals 0 to be the point where the ball leaves your hand. Find the ball's position 3 seconds after it leaves your hand. So they gave us all the information we need. So we're going to use the kinematic equation, which is y equals initial velocity time plus 1/2 at squared. So with that, a is just gravity. So with that, we know VO is the initial velocity, which would be 12.0 meters per second, which they said in the problem. And the time it'll take that we're looking for is 0.300 seconds. And then gravity is usually shown by negative 9.8 meters per second squared. That's because it's usually downward. So with that, we're just going to do y equals 12.0 times 0.300 plus 1/2 times negative 9.8, which is gravity, times 0.300 squared. So with that, you're going to get y equals 3.6 plus 1/2, negative 9.8, 0.09. You compute that all together, it will equal 3.16 meters. So the ball's position after you drop it will be 3.16 meters. And then for part B, it asks you um, state whether the ball is above or below your head or below your hand. Um, it would be above your hand since because the position is positive. Usually, when the position is positive, it means that it is acting upwards, so it would be above. It'd be above your hand in this case. Okay, so with that, we're going to move on to part C, which is find the y component. Actually, no, I got you. It's find the y component of the ball's velocity after 0.300 seconds after it leaves your hand. I'm going to express it with, you know, proper units, but we're going to use the velocity equation, which is simply v of y component, initial velocity plus force of gravity times time, right? So we have these numbers already. So it'd be 12.0 plus negative 9.8, which is gravity. Yeah, like that. And then with that, you're just gonna solve. So that'd be minus 2.94, and then that would equal 9.1 meters per second. Same thing for part D. Since this number right here is positive, the ball is moving upward. Just because this is positive. You'll see this also later on in the problem. Um, it'll also ask why, like it'll also ask this kind of question later on in the problem. But I just use simply the velocity equation and just plugged in the numbers that we've got. And yeah, pretty much as simple as that. Now we're going to move on to part E. So part E asks us find the ball's position 2.6 seconds after it leaves your hand. So this would be the kinematic equation that we used earlier, which is going to be y equals initial velocity times time plus 1/2 the force of gravity times time squared. So with this, we're just going to substitute all the numbers we already know from the past problems. So 12.0 times 2.60, which is what we're looking for, plus 1/2 9.8 2.60 squared. With that, that's going to be the first term. We're going to just solve for the first term, which would be y equals 31.2, and then the second half would be this. So if you compute that, it will be negative 33.15. Put these two values together, you're going to get 31.2 minus 33.15, and that will leave you with negative 1.9 meters. Okay, and now we're going to state whether the ball is above or below your hand. As I said earlier, this number being negative forces it to be below, this is not a hand, but the ball will be below your hand since it's negative, since this number is negative. So for that answer, it will be the ball is below your hand. So for our next one, it will be question F. Part F. Part F states, part G, my bad. Part G, we just did part F. So part G will be find the y component, find the y component of the ball's velocity 2.6 seconds after you leaves your hand again. Um, well, no, we didn't find the y component earlier, but this one is going to force us to use the velocity equation. Sorry about that. Which would be Vy component equals initial velocity plus active gravity times time. So that we're going to just do what we've been doing for the past few questions. Plug in the numbers we do know. Pretty much physics is if you're just making sure that you know certain formulas and just following them with the stuff you're given. So with that, that computes out to be negative 13.5 meters per second. That is what the velocity would be. Okay, say whether the ball is moving upward or downward. 2.6 seconds after it leaves your hand for part H. Um, since this is negative, the ball is moving downward. So yeah, very simple. Usually for these type of questions, if your answer is negative or positive, that depends. That determines where your where your ball is moving. Okay, so for part I, we want to. It states you throw a stone straight down from the top of a tall tower. Use your hand moving at 8.0 meters per second. Air resistance can be neglected. Take the positive y direction to be upward and choose y equals 0 to be the point where the stone leaves your hand. Find the stone's position 1.5 seconds after it leaves your hand. Okay, so it gives us all the numbers we need. We're going to use the kinematic equation again for this one. So let me just delete this real quick. But yeah, we're going to use the kinematic equation. That'll be y equals initial velocity times time plus 1/2 of the force of gravity times time squared. We know initial velocity is 8.00 meters per second. We know the time we're looking for is 1.5 seconds. And we know the force of gravity is usually 9.8 meters per second squared. So, unless you're on a different planet. So it'll be y equals 8.00 times 1.50 plus 1/2 times negative 9.8 times 1.50 squared. We're just going to do the first half, which would be this 8.00 times 1.50, which would equal 12.0. And the other half would be this one, which would equal into a negative 11.025. We're just going to put these all together. 5 equals 975 meters. So since the motion is downwards, position is y equals negative 23.0 meters, and that's what you're going to get for that answer. So for the next one, it'll be for for part J, it's going to be asking you to find the y component of the stone's velocity after 1.5 seconds, like after it leaves your hand for 1.5 seconds. So with that, we're going to just use the velocity equation now. Um, so for part J, yeah, just use the velocity equation and the numbers we already have. So that would be v1 equals vn equals that. Wait, what? No, plus that. To find the y component of velocity, it'll be that equation right there. Just make sure to always write that out, just so you know what equation you're going to be using. So yeah, these are the numbers that we know already, or are given to us blatantly by the problem itself, or that we found out through the work. So you're just going to plug in all the values. So that'd be Vy equals 8.00 plus 98, 1.50, right? So that would be y equals 8.00 minus 14.7, which would equal into negative 22.7 meters per second. So that's what the y component of velocity would be. It would be this negative 22.7 meters per second. Okay, moving on to part K. Simply is asking you for find the y component when the stone is 8 meters below your hand. So for this one, it's going to be we're going to be needing the the energy-based velocity equation. So with that, that one is the new one that we've been that one's a new one in the textbook, but it would be v squared, the y component, equals initial velocity squared plus 2a y minus y0, right? Or y minus, yeah. So we know this. So we know what the initial velocity is. We know the active gravity, like the force gravity, and we know that y minus y0 equals negative 8.0 m squared. That's because it's just below the starting position. Wait, no, it's not m squared. It's just meters. Negative 8.0 meters. So with that, we're just going to substitute now. P squared 8.00 squared plus 2 times negative 9.8 times negative 8.00. Simply, that is v squared blah blah 64.0 plus 156.8, and then that will equal 220.8. So then we want to square root these things. So we're gonna do we're just gonna like do square root. We're gonna square root this side, and then we're gonna square root this side of 220.8. And if you use a calculator, it should approximate to be plus or minus 14.86 meters per second. And since the stone is moving downwards, we want to pick the negative. So we're gonna do Vy equals negative 14.9 meters per second. That's because it's a negative value. Okay, so that's parts K done, I believe. That was K. Yeah, that was K. Let me just make sure to label that. Now we have L, M, N, O, P left, right? So pretty much it's going to be the same kind of methods to our madness. Um, yeah, let me just clear this out real quick, and then I'll get started on parts L, M, N, L, P. Pretty much. Okay, so that's all clear now. We're going to get into L, which is going to be, we know the football speed at a height of y equals 4.0 meters, which is v equals 0.5 meters squared moving upward. And then for this one, we're going to use an energy-based equation as well. So we're going to do v squared equals v initial velocity squared plus 2a times y minus y0, right? So with this one, we know v, it's stated in the problem, 0.500 meters per second. We know y equals y0 is 4.0 meters, because that's what we're finding. And then we know the force of gravity is always going to be negative 9.8 meters per second squared. So we know these numbers, right? So pretty much we're just going to solve using them. Just going to substitute them in. So that would be this. So 0.5 is just simply 0.25 after you square it. I don't need a calculator for that one. So yeah, so 78.4. That one I do need a calculator for. But your answer will be 78.65. But since you want to square root these both sides, you want to do v initial velocity equals, oh wait, no, yeah, equals 8.87 meters per second, and then we're just going to keep it like that since it's positive. So yeah, that's simply, you just got to use the equations that are given and that you know. That is part L. We're going to move on to part M. Let me just erase all this. What does this do? All right, that's not what I want to do. But yeah, we're going to do part M. See if I can put this on the tractor real quick. Oh, no, I can't. Okay. Okay, we're just going to try to wing it. All right. Okay. We're on part M. Sorry for the wait. So the question's asking you how much time elapses from when the football leaves your hand until it is 4 meters above your hand. So this one we're going to use the kinematic equation, y equals initial velocity time plus 1/2 of the force of gravity times time squared. So we know what we're looking for. So y minus y equals 4.00 meters. That's like when the time they left your hand. I mean, that's what we're looking for when it leaves your hand. We know the initial velocity from the previous part, and then we know the force of gravity because, I mean, if you don't know it by now, then are you even in physics? So we're going to rearrange it into a quadratic equation. So that's going to be this pretty much. Okay, that's going to substitute all the values now. Okay, and with that, you're going to get the quadratic equation of negative 4.9t squared plus 8.87t minus 4.00. So with that, you want to use the quadratic formula. Pretty much, so this is what the quadratic formula looks like, obviously. So for these ones, the values will be a equals 4.9, negative 4.9, b equals 8.87, and c will equal negative 4.0. So with that, we're just going to plug in. So it would be t equals negative 8.87 plus or minus the square root of 8.87 squared minus 4 times negative 4.9 times negative 4.0 all over that, yeah, all over that. And then 2 times negative 4.9 at the bottom. Um, with that, you just do the math up there. That would be negative 8.87 plus or minus the square root of 0.29 over negative 9.8. Pretty much that approximates into this 0.54. And then since you want it to be okay, then you're gonna do plus or minus 0.54 over negative 9.8. So you're gonna do T1, which is gonna equal into 0.854 seconds. And then T2 we don't even bother doing since the time must be positive because you can't go back in time. So this means that it takes the ball 0.854 seconds to reach 4 meters. That is part M. Very tedious, not tedious. It's just very just you gotta know your equations. That one we use two different formulas. So yeah. So pretty much just pretty simple stuff when you get to know it and learn the concepts. But yeah, I'm going to start part N now. Just give me a second to erase all this math. Uh, Very math based kind of science, but I think that's good, honestly. It's gotta be easier way to do all this. Yeah. Okay, I think I'm gonna be fine with just the first page. Okay, so we're gonna do part N now. And then this one's simply asking, at what speed does a tennis ball leave your hand if it reaches a maximum height h? Okay, at maximum height, the velocity is zero. So we're going to use a energy-based equation, which is v squared equals v squared, initial velocity squared plus 2a y minus y zero. Okay, so with this, we're going to rearrange it. Zero, we know zero, because they told us it is. 2 minus 2 negative g times h. These are variables that they've given us. Yes. So we're gonna do that. These we're gonna just combine them all together. 2gh, and since you want to single out this other side, you're gonna do the square root of both sides. So that just leave you with v equals 2gh squared, square rooted. So that's the initial speed. So this would be the initial speed right here. Pretty simple. You just use what they gave you in the problem, and then you just use your knowledge of it being that energy-based equation. Okay, so same for this part is going to be part O. Part O. We'll be using the energy equation, which is v squared equals v squared zero. I mean, initial velocity plus 2a y minus y zero. So we know that y minus y zero equals h over 2. I believe this is given to us. Yes, this is given to us. And then v squared initial velocity is 2gh. We just got this from part N. So we're just going to substitute now. Let me just put that on. Okay. So we're just going to simplify it to be v squared equals 2gh minus gh, which is equals gh. And then we're going to square root both sides. So that'd be v equals square root of gh. And then to find this, we're going to find a fraction. So v equals a v over the initial velocity, which would just be this equation. And then if you know that square root of 1 over 2 is just 1 over radical 2, you would know that would equal 0.71. Thus, v equals 0.71 that is going to be um, initial velocity. So we're going to make sure we put that correctly. So that's going to be that. For the final part of this very lengthy, very lengthy problem. Like I saw it and I was like, yo, A through P, are we serious? Well, obviously, obviously I did it. So, just give me a second to erase all this off my screen. So for our last and final problem, is going to be part P. Part P asks you, at what height above your hand is the speed of the ball half as great as when it left your hand? Express your answers in terms of h. So if the speed is half as great, that would be v equals initial velocity over 2. So we're going to use the energy equation this time to do v squared equals v initial velocity squared plus 2a. Yep, we know all this stuff. So we're going to do initial velocity over 2 squared equals v squared initial velocity plus 2 minus 2 negative g, 2 times negative g. There's a lot of yapping there. So we're just gonna do initial velocity over 4, initial velocity squared over 4, initial velocity squared plus 2 minus negative g still. No, what? No, I need to just make this, okay, my bad. This would just be minus 2g still times this variable stuff. Then we're just going to rearrange it to be 2g minus this is, and then we're going to do, what? That's not the right term. Okay. Okay. Initial velocity squared minus initial velocity squared over 4. So with that, we can solve, and we can multiply both sides by, what did we do? Oh yeah, we can do, yeah. Give me a second. I need to like locking. Okay. 2g minus 0 equals 4 squared 0 minus v squared 0 over 4 equals 3v squared 0 over 4. So then if you multiply both sides by 2g, that will equal y minus y0 equals 3v squared 0 over ag, because you multiply both sides by 2g. So with that, you'll find that 3 times 2gh for he equals 3h over 4, giving you your final answer of y equals 3h over 4. A lot of math, a lot of equations, but as long as you know them, you should be pretty fine. Thank you for sitting through this video. I'm not too sure how long it took. I hope it's not long. But yeah, this should be updated by tonight. But yeah, thank you for watching and hope you guys have a good night.